Hello dear grade 11 students to our new chapter, the sign of the quadratic functions. Well, this chapter is related to the previous one. It's related to quadratic equations, and we are going to use the ideas of the quadratic equations in explaining this chapter. This chapter is prepared by Mr. Adnan Ashar. Big thanks to him. And here we go with the first idea of this chapter. All what we care about is to discuss and to know the sign of a quadratic function that's usually in the form of ax squared plus bx plus c. Here are graphs because graphs are going to help us understand the idea more clear and perfect. Here is the rule in case of delta less than 0. Okay, what is delta? Let's remember. Delta is b squared minus 4ac that we used a lot in the previous chapter. So, if delta is less than 0, this table says that the function is defined on R from minus infinity to plus infinity on the table, and we have here the function t of x, and we have the word or the sentence same sign as a. What's that? So let's use the graph. Let's use the written here in order to understand this rule. So, look at this graph. This graph is of the function x squared minus 2x plus 3. Okay? Notice that this graph is above the x-axis. That means that it is positive. Positivity means above the x-axis. Negativity means below the x-axis. Notice that this curve is not intersecting the x-axis. That means there are no real roots. So, this curve tells us that the function is positive because the curve is above x-axis. It also tells us that there are no real roots because the curve is not intersecting the x-axis at any x-intercept or at any point. Let's make sure. First of all, we find delta. Delta, applying this rule, is b squared minus 4ac, and the result is minus 8. Notice that delta is negative, so definitely no real roots. That's why no intersection with x-axis. Now, what is a and why do we care for a? A is the number multiplied by x squared, the coefficient of x squared, and here it is 1. So a is 1, which is a positive number. Now, let's make a relation between the sign of the function that's written plus here and a and delta. And we can then understand the written here. So, no one has a doubt that the sign of this function is plus because, you see, it is above the x-axis. So definitely its sign is plus and it's defined over minus infinity plus infinity. No roots. Notice no roots and no number here. So it's just strictly positive. Okay, what does a have to do? What does delta have to do? Notice that delta is negative and a is positive. Notice that this sign is like the sign of a. Let's go to the other example to make things clear and to get the rule perfectly. Here is the second example. The function here is minus x squared plus x minus 1, and this is its graph. Notice that the graph of this function is directly below the x-axis, and it's not intersecting the x-axis. That means that the function is negative because its curve is below the x-axis and it has no real roots. So, because this function or this curve is not intersecting the x-axis at any x-intercepts, then definitely no real roots. Let's make sure by calculation. Delta here equals minus 3, which is also negative, which means no real roots. That's true. A here is the number multiplied by x squared, which is minus 1. Then a is negative. Let's see the table here. X, t of x, the function here is t of x. It's defined over minus infinity plus infinity, and there is a minus sign here to tell us that the sign of this function is negative. Why? Using the curve, because it's below the x-axis, and if we are going to relate things together, delta is negative, A is negative, and notice that this sign here is going to the sign of A. So it's related to the sign of A. So that's why we have to say that if delta is negative, then we have to look at A and the function takes the sign of A. And this is the first rule. So to know the sign of a function when delta is negative is just to look at A. If A is positive, then this function is positive, as you see here. If A is negative, then the function is negative, as you see here. And here is the table we need to draw. So we write in the first row x, then t of x, and usually it's defined because it's like a polynomial. A quadratic function is defined over r from minus infinity to plus infinity. And here we put the sign and no roots in the middle between minus infinity and plus infinity. What do we have also? Let's continue. Now the case of delta equals 0. So the second case, if delta equals to 0. Also, we have like a rule here, and we are going to understand this rule. Where does it come from? Using the graph. Look at the first function whose curve is this. The first function is x squared minus 4x plus 4, which is the perfect square x minus 2 squared. Okay? So definitely there are here two equal roots, or we can say there is a double root, which is only 2. Notice the root means the point where, or the x-intercept, where the curve intersects the x-axis. Okay? So the curve intersects the x-axis at 2. Here is the x-intercept. It's just one root, one value. So x prime equals x double prime equals 2. Now, let's read the written here. The curve is above x prime x for x belongs to r minus 2. So as you see, here you have from minus infinity to plus infinity. So as you go that way, you are, or the curve is above the x-axis. And as you go that way, also the curve is above the x-axis. But at 2, what happens to the curve at 2? It intersects the x-axis and the x-axis becomes a tangent to that curve. So the curve is above the x-axis for any x not equal to 2. Okay, r minus 2 means for any x belongs to the real number set except 2. But at 2, the curve is still above the x-axis, but at 2, the curve touches the x-axis at only one point, which means that the x-axis or the curve and the x-axis are tangent at x equals 2. Let's relate these ideas to delta and to A. Notice again, delta here equals to 0. Okay, if we calculate delta, we can definitely notice that it's equal to 0. A is the number multiplied by x squared. We take the expanded form. A equals 1, that is positive. So the root, we put the root in the middle, which is 2. And minus infinity here and plus infinity here because that's the domain of definition. X here and t of x here. And notice that. Let's translate these into the table. The curve is above x prime x if x belongs to r minus 2. Above x-axis means plus. So above x-axis, if x is not equal to 2, so from minus infinity till 2, we have plus, and again from 2 to plus infinity, we have another plus because the curve is positive. At 2, the curve meets the x-axis at this point, so we put a 0. That means the abscissa of the point of tangency between the curve and the x-axis is 2, and its ordinate, if you substitute here in the initial function, you will get 0. So we put 0 at the root. Before the root, it is plus, and after the root, it is always plus. It is also plus, and this plus is related to the sign of A. So again here, we take the sign of A if delta equals to 0. But the difference between this case and the previous case is that there is a root in the middle. But in the previous case, when delta is not 0, we don't have a root in the middle. We just put 1 plus sign or 1 minus sign. Another example to make things clear. If t of x equals minus x squared plus 2x minus 1, which is minus into x minus 1 squared, so it's definitely negative. This value is always positive, and a minus before it, then it's definitely negative. Let's move to the curve. Notice that the curve of this function is going downwards. It is negative. It is below x-axis. Below x-axis means minus. And also, it intersects the x-axis at only one point that we call a point of tangency, which is of abscissa 1 and ordinate 0. So again, the curve is below x-axis for any x not equal to 1, for any real number x that's not equal to 1, at 1, when x is 1, okay, then the curve is tangent to x prime x, and this one is definitely the root, the double root. So if delta is 0, here we have a double root which is 1. We put it on the table. We put minus infinity plus infinity. We put the root on the table, and we put minus because as you see, the curve is below the x-axis. But later, you don't have to draw curves to know it. You can just use the rule. So you just notice what is delta, if it is 0 or negative. If it is 0, we have a double root. You can calculate the root using the calculator or using factorization or whatever. So you put the root on the table. Here is its abscissa. Here 0 is its ordinate. You put minus infinity plus infinity, and the minus sign here comes from the sign of A. So in all cases, if delta equals to 0, we have to take the sign of A, which is minus here and plus here. So again and again, we put the row for the x and the row for the function, minus infinity plus infinity. We put the root in the middle and 0 on the root because its ordinate is 0. And we spread the sign of A before the root and after the root. Similarly for here, we put the sign of A before the root and after the root. So the curves are just for making things clear, because we don't have to draw curves every time. All what we have to do is to look at delta, to look at the sign of A, and to complete the table to know the sign, or to study or to discuss the sign of the quadratic function.